In this segment, I'm going to talk about why NLP researchers adopted an empirical approach using data and statistics for making progress on the problem of parsing the structure of human language sentences. What was the situation that existed before that? Well, the classic way of parsing, by which I mean before 1990, was that people would write a grammar, which might be a phrase structure grammar or context-free grammar. Those two terms are equivalent, or might be in a more complex format, and a lexicon, so something like this baby example that I've shown here. And once you had a grammar of that sort, you could then use a grammar parsing system or a proof system to find allowed parsers for a string of words. The problem with this approach is that it's scaled very badly to the kind of sentences that people typically write and say, and didn't give a suitable solution to that problem. Let me try and give some indication of the problem. So consider the full version of this sentence that we've used as an example before. Fed raises interest rates 0.5% in effort to control inflation. If I, as a linguist, write a grammar that's not completely crazy, but is the smallest possible grammar that can parse that sentence, and then say, parser, parse this sentence, what I find is that the grammar already allows 36 parsers for that sentence. If I write a slightly more general grammar, which will allow other things that commonly happen in natural language sentences, well then suddenly my grammar allows 592 parsers for this sentence. And if we then look at the kind of broad coverage grammars that are actually used in the statistical parsers we'll talk about soon, and I try and parse this sentence, I find that this sentence has millions of parsers. So you can see that we've got a problem that's kind of out of control. So classical parsing was stuck between two problems. On the one hand, you could try and put a lot of constraint on grammars to limit their ability to generate weird and unlikely parsers for sentences. But the problem was that to the extent that you did that, the grammar became very non-robust. So it was quite common in traditional systems that even if you gave them well-edited text like newswire articles, that something like 1/3 of the sentences would have no parse whatsoever. But on the other hand, if you made the grammar looser so it could parse more sentences, what you found is that even extremely simple sentences started getting more and more unlikely and weird parsers, and you didn't have any good way to choose between them. So what we need is a system of grammar that's flexible enough that it can deal with the flexible ways in which humans use language in their daily life, but is predictive enough that it will allow us to choose the correct or likely parse for a sentence. And so that's precisely what the statistical parsing systems that we'll look at in these lectures allow us to do. How can you build a statistical parsing system? That's where the topic of data comes in. And so the huge enabling factor for being able to build statistical parsing systems was the development of tree banks. And here I'm showing an example sentence from the Penn tree bank, which was the earliest widely available tree bank and still the most famous. So we've shown examples of tree bank sentences before, but what you actually get in the tree bank is these kind of structures. So the sentence tree structure is being indicated by these parentheses, which are nested to show constituency. If you're an old-time Lisp programmer, this should look to you like, and indeed is, Lisp S expressions. So this is giving the structure of a sentence with noun phrases and verb phrases, and various other things. So the markings also will indicate empty elements of various kinds, and also sort of various functional annotations. So this says that this is the subject of the sentence. And so once we had this kind of annotated data, we're then in a position in which we can use machine learning techniques to train parsers to say what is the most likely parse for a sentence. We're also in a much better position to build robust parsers because we have a lot of sentences that give us some kind of indication of what kind of flexibility of structure we need to admit into our languages to be able to parse typical language use. And so this was a revelation that if you're starting off it actually seems like building a tree bank is a lot of work with very low payoff, because the whole power of writing rules of grammar is you can write one rule and it generalizes to thousands, millions, in fact an infinite number of possible sentences, whereas building a tree bank, you're taking one sentence at a time and parsing it, so that seems slower and less useful. But actually a tree bank gives us many useful things. It gives us reusability. Normally the parser of one person was completely not used in developing the parser of another person. It was done completely independently. But now we've been able to build many parsers, part of speech takers, etc., of Penn tree bank data. And it also has other wider uses. So for example, many linguists now use the Penn tree bank as a source for testing out and developing hypotheses about language. The Penn tree bank gives us something that is broad coverage. It gives us the statistics that will allow us to choose between parsers. And it gives us another thing that's improved to be incredibly important. It gives us a way to evaluate parsers on a common test bed so that we have good data on which parsers are better or worse than other parsers. Now, of course, these days the Penn tree bank isn't the only parser. There are now dozens of tree banks. There are both tree banks for different languages and tree banks for different genres. The original Penn tree bank was just Newswire. It's been extended to some other genres, but now there are other tree banks that cover things like, well, biomedical English is one popular domain, but also other things like looking at various kinds of informal texts and more specialized kinds of English usage, such as tree banks of questions. Okay, so I hope that's motivated for you why it's been important to take an empirical approach in developing parsing systems for human languages, and the great value that we've been able to get from having data resources like tree banks.